4.
Very good. It is 4, okay? So what it's asking for when you have the square root is what number times itself gives you that number underneath. 4 times 4 gives me 16, so the answer is 4. What about the square root of 64? Allison? 8. Very good. The square root of 225. 15. Very good, Miguel. All right. Did anyone get the square root of 2025?
45.
Hey, yo. Very nice. Number 5. How'd you get that? You used a calculator or no?
No.
Wow. 240 is correct. Miguel, you're the first person all day. Number 6. Yeah. 36, square root of 36 is 6. What about number 7, the square root of 400? 20. Very good. The square root of 4 is 2. And the square root of 3,600? 60. Okay. I want you to notice something about number 7 and number 9. Okay. Notice how many zeros there are. Do you see how we're taking the square root of a number with 2 zeros? Your answer should have one of those zeros, right? Because 20 times 20, right? The 2's multiply, you get 4, and then you have 2 zeros afterwards, okay? Same thing with number 9, right? We look at number 6. The square root of 36 was 6. The square root of 3,600 is going to be 6D, okay? They added a 0. All right. Any questions on 1 through 9 from the warm-up? Okay. What number technically is supposed to go in front of that radical for all of these equations? Not a 1. It's a 2, okay? Because that's called the square root. Does anyone remember what that number is called? Yes, very good. It's called your index. Good, Gabby. Okay? It's called your index. So what we're doing today, right, is we are going to be given square root like radicals where we don't know the square root of the number underneath. And we're going to have to simplify that value until its most basic, simplest form, but we will still have a radical at the end. So they're not going to be perfect squares necessarily, okay? All right, so this entire chapter involves the radicals, okay? So we're going to be dealing with radicals a lot. And we're going to be using properties of radicals. And the first thing we're going to learn about is a radical expression. That's just like these. Any expression that contains a radical, right, which is this symbol, is a radical expression. And an expression involving a radical with an index n, so if we put an n here, we can change that number of n, right, to be a different index. It could be 3, it could be 4, it could be 2, okay? It's in simplest form when there are 3 conditions met. And these 3 are those 3 conditions. So label them 1, 2, and 3, please. Natalia? Yes, you may. So the first condition says, no radicands can have perfect nth powers as factors other than 1, okay? What that means is, if we have the square root of 4, we should never leave the square root of 4 just sitting there. What can we always change the square root of 4 into? The number 2 without a radical, okay? So we're not going to leave radicals in our expression at the end because then it wouldn't be completely simplified, okay? The second thing says is no radicands can contain fractions. That means you cannot have a radical with the number 1/4 underneath. This is a big no-no, okay? If you leave your answer like this, you will lose a lot of points, okay? You cannot have a fraction underneath the radical. Write that one down for number 2. And number 3, it says no radicals can appear in the denominator of the fraction. So you're not going to be able to leave your answer as 1 over the square root of 2. This will not be able to happen, okay? You'll have to be able to simplify it, all right? And we're going to start one at a time, and I'm going to show you how to simplify these in each case, okay? The first property that we're going to use is something called the product property of square roots. What does the word product mean, guys? Bruce, what'd you say? Multiply. Very good. So in order to use this property, guess what symbol needs to be there? The multiplication symbol, okay? And what that property says is it says if you have two numbers that are being multiplied underneath your radical, right? For example, 9 and 5, you can do what with their square roots? How did they go from here to the second one? From here to here. What did they do, Josh?
Splitting the radical in half.
Excellent. They split it up. But you're only allowed to do that when this is what symbol? Multiplication. If this was a plus sign, could we apply this?
No.
If this was a minus sign, could we apply this? No. Has to be either a multiplication, and we're going to see in a little bit later, it can also be a division symbol. Okay? Josh, was that your question? Okay. Now, why is this useful? Well, 9 times 5 we knew is 45. We don't know the square root of 45, but when we break it down, do we know the square root of 9? Yes, so we can simplify that to 3. Do we know the square root of 5 though? No, so we get stuck with this one as part of our answer, okay? But this would be completely simplified. Because you could break down the 9 and take the square root of it, you should always pull out anything that is a perfect square, okay? All right, so in order to simplify all of our expressions, the numbers that are perfect squares become super critical. So let's list some of them out on the left-hand side of our page. What are the perfect squares? Let's start with 2. What's 2 squared? What's 2 to the second power? 4. What's 3 to the second power? 9. What's 4 to the second power? 16. 5 to the second power? 25. And 6 to the second power? 36. Do you guys agree this list goes on and on? All right, so let's just put some dots. So what we're looking for, guys, is we're going to look, okay, if any of these are factors of the base of our square root, we want to be able to factor those out so we can pull them outside the radical, okay? So let's start with 108. Which of these factors do you think is going to be a factor? Which of these perfect squares is going to be a factor of 108? Alicia? 9. Let's do it. So we're going to do 108, and we're going to divide it by 9. Alicia's seeing if 9 is a factor of 108. How many times does 9 go into 1? None. How many times does 9 go into 10? 1. So we subtract what from 10? 9. And we get 1. Very good. What do we do next? Bring down the 8, and we get 2. So we subtract 18. Do we have a remainder? No. So 9 and 12 give me 108. Do you guys agree? So watch this. I'm going to rewrite this 108 as what two numbers multiplied together? 9 and 12. So it's going to be the square root of 9 times 12. Who is with me so far? Give me a thumbs up or a thumbs down so far with what I've just done. Okay. Now, based on the property that we just learned, guys, what can I do with these two values? You can split them up. Very good. So we're going to say, okay, this is the square root of 9 and the square root of 12. Do we know the square root of 9 or the square root of 12? What? 9. What is the square root of 9? 3. So we're going to put a 3 here without a radical now because we just found the square root of it, right? And we have the square root of 12. Now, you're not done until you look to see if we can do that again. Does the square root of 12 have a factor that's on the list that we put on the left? Which one? It's divisible by 4. So let's break down the 12. So it's going to be 3 times the square root of, what did we say? It was 4 times 3, because 4 times 3 gives me back to 12. Talk to me. How are we doing so far? We okay? We split it up again. Who said that? Nathan. Very good. So we split it up again. We're going to get 3 times the square root of 4 times the square root of 3. What'd you say? 2 times 2 gives me 4. Very good. So this is 3 times 2 times the square root of 3. Which numbers do you think I multiply? The 3 and the 2. Why do I multiply those two? Because there's a multiplication symbol. Well, why can't I multiply this 2 and this 3? One's outside the square root and one is inside the square root. Do you guys see that? So we multiply this 3 and this 2 and we get 6 times the square root of 3. Now, I'm going to tell you guys we stop here. Why do you think we stopped here? You can't split it up. 3, its only factors are what? 1 and 3, right? So, and do we know the square root of 3? No, so we're stuck, right? You want to get stuck. You want to get to the point where you can't break this guy down any further. Now, do not try to break down the 6, because the 6 is already outside the square root, right? So don't keep taking the square root of it. If it's outside the square root, it's not part of your radical anymore, okay? Talk to me. What questions do we have on this first example? Alec. This part? Okay, so all we're doing at this point, right, was we noticed, okay, the square root of 12. We always want to try to break that down further. And we notice that 4 is also a perfect square, and 4 goes into 12 3 times. So we broke it down into 4 and 3. We split it up again, and we got 2.
For that, we don't put 2 times 2, just put 2.
You just put 2, yeah. Because 2 times 2 gives you 4, which is the square root of 4. Kind of? We're going to do more examples. Gabby?
How big of a number is gonna be like
I don't know. Pretty large. Yeah, Sansia? Why what?
Why pick 9
Why I picked
in
9?
the beginning?
Okay. Alicia picked 9 because she was looking at this list, right? And she just was like, I don't know, maybe let's try 9, right? You could have picked 4. You could have picked 16. You could have picked 25. But you had to check to see if they divided into 108, if they were a factor, okay?
Okay, so not all of them will work.
Not all of them will work, okay? 4, I will tell you, will work. And actually 36 would work as well, okay? Yes. Yes, you may. All right, good questions. What other questions do we have on example A? Okay, let's check out example B. Nope, we're going to go to C first. We'll go back to B. Let's do C first. The square root of 24. People are shaking their heads. We can't break it down any further. All right, let's look back at our list. Is 4 a factor of 24?
Yeah.
All right, let's start there. So what can we break down 24 into? That involves 4. 6 and 4. Excellent. So let's rewrite it. It's going to be the square root of 4 times 6. You guys with me? What can I do at this point? You split it. Very good. So it's going to be the square root of 4 and the square root of 6. Which one of those do I know? The square root of 4. That becomes a 2. Now remember, can we still continue to break down 6? Sure. 6 is what 2 numbers multiplied together? 2 and 3. But ask yourself, are 2 or 3 perfect squares? No. So can we actually break down the 6 anymore? No. Okay, you can break it down to the square root of 2 times the square root of 3, but if it's not a perfect square, you don't have to keep going. So we're stuck at the square root of 6. And we're done. Questions? Talk to me. You have a question? What's your question, Natalia? You can say it. Oh, okay. Then why'd you shake your head yes? Okay. All right. Let's move on to D.
Yes, sir.
Yes.
So you're saying that so if it's like multiplied by an odd number and not two even numbers, we don't simplify it?
No, it has nothing to do with odd or even. Alec, what we're looking for is we're seeing, okay, do any of these numbers, can I factor them out of the number underneath the radical? And if I can, then I want to factor that number out. Okay? Let's take a look at D, guys. How is D slightly different than the other two? There's a negative in front. Should we freak out? No. Okay? Well, guys, we will not freak out, okay? So we're just the negative's just gonna come along for the ride. So we're gonna put negative out in front. Let's try to break down 80 into 2 factors where one of them is a perfect square. Josh? 4. Very good. It's going to be the square root of 4 times the square root of 20. Very good. Okay. Do we know what the square root of 4 is? Very good. It's 2. So it's going to be negative, and then we're going to have a 2 now. And then the square root of 20 still. So now 20, we're like, okay, can we break that one down further? Someone said 10. That would be 10 and 2, right? But that's not helpful because is 10 a perfect square? Is 2 a perfect square? No, so let's only think about the perfect squares. 5 and 4, very good. So we're going to do negative 2 times the square root of 4 times the square root of 5, yes? All right, but what was the purpose of that? Because which one do we know? The 4. The square root of 4 is what? So we have negative 2 times 2 times the square root of 5, yes? All right, what do I do from here? Negative 2 times 2, which is? So I have negative 4 times the square root of 5. Am I stuck? Why? You can't break down the 5, so this is my answer. I'm done. Oh. A little bit? Yeah, Sansia? Ooh, very good question. Guys, I need you to pay attention to Sansia's question. Can you ask it a little bit louder? You absolutely know that the square root of 4 is 2. But I have a question, Sansia. Is there a radical above the 4? No. So when there's no radical above the number, it's already been pulled out. You don't want to touch it. Okay? Yes?
Why did, for the one that has the square root in it,
Yep.
why would we make it 2? Why does it go away?
Well, what is the square root of 4, right? What number times itself gives you 4? And the answer is 2, right? So do you remember in the warm-up, right, Charlie? How we were writing those values were equal? I know that these two are equivalent. The square root of 4 is 2, and 2 is the square root of 4. So I can replace them either way, okay? Kind of?
But for 20, you put square root 4 and 5. So those kept it, but for 2 went away.
Yeah, because 4 times 5 gives me 20, right?
Yeah, but how come they have the radical side on?
Because the 20 was underneath the radical.
But so is the 4.
Yep, the 4 was underneath the radical, but we know the square root of 4, so we pull it out. Do you know the square root of 20 here, Charlie? No, so you have to break it down so you can simplify it. Okay? Yes. What other questions, guys? Josh? You sure? Okay. Can we now look at B? Gabby?
So whenever we find the square root of like the number after you break it down, that's what you put outside way?
All right, let's break this one down. What operation is going on underneath the radical? Multiplication, okay? What can I do when multiplication is down there?
You gotta flip it.
No.
Split it.
Split it. You can split this up into the square root of what? 9. And the square root of? X to the third. Do we know the square root of 9? Yes, that is 3. So it's going to be a 3. No radical. And the second half, which is the square root of x cubed, let's try to break that down further. X times x times x. You guys agree? But are any of these perfect squares? No. So let's merge 2 of them together. Let's make one of them x squared. Why would that help me? What's the square root of x squared? X. So check this out. We're going to get 3. Are we able to find the square root of just x? No. So that one stays the same, the square root of x. But we know that the square root of x squared is just x. So now, guys, when you're writing your final answer, all the terms that are outside the radical come first. All the terms underneath your radical come at the end. So how do you think I have to write my final answer here? Josh?
3x and then x. And then square root of x.
And then the square root of x. Very good.
Oh, okay.
All right, talk to me. What questions? What questions do we have? Sansia?
So why did you put the X next to the three?
Why did I put the X next to the thing? I need a little bit more description.
No, sorry, the X is 3.
Next to the 3. Okay, because we write our answers, right, with all the terms that are not under a radical first, and all the terms that have a radical as the last, okay? If you left it like this, it's not a big deal, okay? But just get more into the habit of writing it like this. Yeah, Sienna. Yes, you may. All right, let's letter E. What do I do in letter E?
2 factors.
2 factors? What do you mean?
And you have to break down the X.
Okay. So start me off, Natalia. Go ahead.
7 times. 14.
No? What are you saying?
No, I was counting.
Oh, you were counting them. Okay. Does 49 have a square root?
7.
Sure does. It's 7. But first, before that, guys, aren't these being multiplied? Okay, so can we break it up into the square root of 49 and the square root of x to the 3rd? You got to do that first. Yes, and then the square root of 49 is 7.
Times 7.
But you can't square it.
No, we're not supposed to, right? Because, Josh, once we find the square root of 49, it becomes 7. No square root anymore. Okay? So the square root of 49 is 7. The square root of x cubed, we're going to break that down into what? X squared and x. Very good. Because the 2 plus the 1 gets me back to 3. You guys agree?
Yes.
All right. Do we know the square root of x squared? It's x. Do we know the square root of x? We leave it because we're stuck. And that's our answer. 7x times the square root of x.
Can I use the restroom? Let's see what it is.
Mm-hmm. All right. F. Yeah. You're lost on this one?
Mainly most of them.
What's that?
I'm just lost on like
The whole thing? Okay. Can you come to office hours today? Perfect. All right. Letter F. We've got the square root of 75 n to the 5th. What do I do first? Break it down. Split it up. So it's going to be the square root of 75 and the square root of n to the 5th. What do I do after that? What's that? N to the 2nd. Okay. I'm going to tell you there's a greater perfect square that we should factor out of n to the 5th. N to the 4th. Very good. Let's break this down into the square root of n to the 4th and the square root of n.
15 times 5.
15 times 5 gives me 75. Are 5 or 15 perfect squares? Mm-mm. Let's think of a different number. You're close, though. Remember, let's list out our perfect squares. They were 4, 9, 16, 25, 36. Guys, are any of those going to be able to go into 75? 25, very good. This 75 is going to break down into the square root of 25 times the square root of 3. Very good. 3/4 give us 75 cents. All right. Yes.
I'm thinking, like, how do we get that part wrong? Like, how? I don't know. Never mind.
Are you sure?
Yeah.
Ask which part are you talking about? The
Like,
first
like-
part here or this second part?
Just like picking the number.
Oh, picking the number.
Like confused.
So picking the number, you have to pick from this list, okay? Because if it's not part of that list, then you're not going to be able to simplify it, right? So 4 is an even number. It's not going to be able to go into 75. 9 we could definitely try, okay? But when I do 75 divided by 9, I think it goes in, it's going to be 72 because it would be 8, right? 8 times 9 is 72. And I get 3 remaining, so it doesn't go in evenly, right? So you're like, okay, it's not going to be 9. Can't be 16 because that's also an even number. So then you would be like, oh, 25 maybe, right?
Also, there can't be a remainder.
Correct. There cannot be a remainder. It has to go in evenly. Alec? Yes, you may. So we're going to do the square root of 25 times the square root of 3. That will give me the square root of 25 we already know is 5 times the square root of 3. What is the square root of n to the 4th? N to the second power. And then the square root of n. So we're going to put, remember, all the terms that are outside your radical first, and then all the terms that are under your radical second. How do you think I rewrite this? 5n squared. What's that? You need to repeat that one more time. You got it? And then what goes underneath my radical? 3 and n, and they're multiplied. Yeah, Charlie? Where'd I get into the 4th? Right? So Charlie, this was a square root, right? So I want to pick a number, or I want to split it up so it has a perfect square. N to the 4th, right? Do you guys agree that n squared times n squared would give me n to the 4th? So then the square root of n to the 4th is n squared. Because we're looking for two values that when you multiply them by themselves, by each other, they give you that value underneath. So the square root of n to the 4th is n squared. You guys, what would be the square root of n to the 8th? N to the 4th, right? What would be the square root of n to the 16th? No, not to the 4th. The 8th. Because you guys, n to the 8th times n to the 8th, do you agree we add those exponents? And we get n to the 16th? What would be the square root of n to the 6th? N to the 3rd, okay? What would be the square root of n to the 18th? N to the 9th, okay? Does that make a little bit more sense now?
Coach.
Hey.
Hey, Coach. Can I just pop this door open and run some?
Yeah, go for it. Mm-hmm.
You're supposed to be looking at a Kahoot, but they're a loud group.
Okay.
Is that gonna bother you?
I can stand there, it's fine. Let's do the square root of 72. I want you to simplify it.
Are you okay now?
Yep.
They're a loud group.
All right, let's talk about it. So, what can we factor out that's a perfect square from 72? Natalia? 16 and 4. 16 times 4. 4 times 6 gives me 24. Bring up the 2. 4 times 1 gives me 4 plus 2 gives me 6. That's 64. That will not work, Natalia. What? 9 times 8 will work. 9 times 8, the square root of 9 times the square root of 8. Why is that helpful? Why am I excited that I picked 9 or 8? Which one's more important? The 9. Why is the 9 important? No, not that it can be factored. It has a perfect square, right? What's the square root of 9? 3. So we have 3 times the square root of 8. Guys, can we keep going? You sure can. What's a perfect square that goes into 8? 4 and 2. So we have the square root of 4 and the square root of 2. Which one of those is important? The 4. What's the square root of 4? So we have 3 times 2 times the square root of 2, which is 6 times the square root of 2. Are we stuck? Why are we stuck? Why are we stuck?
You can't go any lower.
You can't break down the square root of 2. So we're done.
I got it, Mr.
You got it? Yeah. Can I show you the easy way to get it? So, the easy way to get it, right, is to pick a larger number, as large as possible. There's a larger factor of 72 that's a perfect square. 36 times what? 2. What's the square root of 36? Did we get the same answer? A lot less steps on the right. Do you guys agree? Try to factor out the largest perfect square as possible, okay, that you can at the start, okay? Can we do another one? So the square root of 50, right? We can absolutely break that down into the square root of 25 and the square root of 2. Why is that helpful, Miguel? 5 and the square root of 2. Okay, and that is our answer. That's it. Well, we're stuck because do you know the square root of 2, Sienna? Does 2 have factors that are perfect squares? Then we can't move on. Okay? All right, guys. The next set of examples is when we have division. Okay? So it's going to be the quotient property of square roots. Okay? So we're going to be dividing. You're going to see fractions. We apply the exact same process. You just split up the radical. Okay? So if we have the square root of 3 over 4, it turns into the square root of 3 over the square root of 4. Okay? It's pretty much the exact same thing as multiplying. Okay? So let's take a look at letter A. We've got the square root of 15 over 64. We're going to start these problems by splitting it up from the beginning. We're going to do the square root of 15 over the square root of 64. Do you know the square root of 15? No. Are we able to factor it to a perfect square? What would you try? 5 and 3, right? But are either of those perfect squares? No, so are we stuck in the numerator? Sure, so we're just going to leave it as the square root of 15. Do you know the square root of 64? What is it? It's 8, very good. And that's my answer. Yeah, Sienna? No. That's the answer. Yep. B. Okay, so what do I do first? What did I say to do first? Split it up. So it's going to be the square root of 81 over the square root of x squared. 9 over x. That's my answer. That's it. Remember, guys, all we're doing is simplifying, okay? All we're doing is simplifying. All right, let's take a look at the next one. Let's take a look at letter C. We have the square root of 28 or 23 over 9. What do I do? Split it up. So it's square root of 23 over the square root of 9. Do you know the square root of 23? So, but wait, before you leave it, you should look for what? Factors that are perfect squares, right? Does 23 have any factors? No, other than 1 in itself, it has no factors. So we're going to leave it. It's going to be the square root of 23. What about the square root of 9? 3. So we're done. What? There's a negative? Oh, in letter D. Okay, what do I do here? What? Yeah, split it. So it's going to be, don't forget the negative, square root of 17 over the square root of 100. What can we do with the square root of 17? Nada. You can't do anything. So negative square root of 17 over 10. Because the square root of 100 is 10. Talk to me. Better? Okay. Let's move on. E.
6. Sorry. Break down. 6 over Z.
6 over Z. All right, let's take our time here. Let's take our time here with that. What do I do first? Let's write out all of our steps. Split it into what? So 2 radicals. 1 in the numerator and 1 in the denominator. Then you split the numerator. Very good. It's going to be the square root of 4 and the square root of x squared over, what's the square root of 64? 8. Do we know the square root of 4? Do we know the square root of x squared? This is wrong still. Someone tell me why this is wrong. Why is this wrong? What about 1/4? You have to simplify. Do 2 and 8 have a common factor? What is their common factor? 2. Divide them both by 2, you get 1 over. So my answer is x over 4. What questions do we have so far? All right.
Would 1 over 4 work or only x over 4?
What? 1 over 4x would also work. Like 1/4 x, that would work as well. All right. Next, we are going to also talk about cube roots, okay? So when we're talking about cube roots and we want to simplify them, right? We're not going to talk about the perfect squares anymore. We're going to talk about the perfect cubes. So we're going to talk about 2 cubed, 3 cubed, 4 cubed, 5 cubed, and so on. So we're looking for these perfect cubes to be factors of our radical, whatever's underneath the radical. What is 2 cubed, guys? 2 times 2 times 2. It's 8. Very good. What's 3 cubed? 27. Excellent. What's 4 cubed? 64. And 5 cubed, does anyone remember? 125. Excellent. So this list continues to go on, but we're looking for one of these. If we can factor it out of whatever's underneath the radical, then we can simplify. So let's look at letter A. What do you think would go into 128? Sansia? There's not enough time.
4 cubed.
4 cubed, 64. Very good, Natalia. We can break this 128 into the cubed root of 64 times the cubed root of what? 2, because 64 times 2 will give me 128.
What to do with the next?
Now, I've intentionally made a mistake. I forgot something. What did I forget? The negative. Does it matter which of these factors is negative? No. So pick one and make it negative. I'm going to make the 2 negative. All right. Now, why did Natalia pick 64? Do we know the cubed root of 64?
Yeah.
What is it? 4. Cubed root, not square root anymore, cubed root. And do we know the cubed root of negative 2? No. So we just leave it as the cubed root of negative 2. We're done. Now, you will see that answer. Sometimes they'll pull the negative outside. It could be negative 4 cubed root of 2. Okay? Either of those answers, they're both the same. You will see both. Huh? No, not yet. Letter B. We've got the cube root of 125. X. First thing you got to do is split it up. So let's split it up into the cube root of 125 and the cubed root of x to the 7th. Oops, not 4th. Do we know the cubed root of 125? Not 25. It's 5. Why is it 5? What's 5 times 5? What's 25 times 5? So do you guys agree 5 cubed is 125? So the cubed root of 125 is 5. Now, we have to break up the second one. We want to break it up so that x's exponent is divisible by whatever the index is. So we're going to have the cubed root of something and the cubed root of something else. What do you think goes underneath this first one? X to what power? The 6th. Very good, Melanie. And then the second one is just going to be x. Because we used 6 of our x's in the first one. We have 1 left over to make 7. This is going to be 5. This is going to be x to what power outside the radical? To the 2nd power. And then the cubed root of x on the inside. Turn these into the 7th. Oops.